Hello and welcome. In this video, I want to show you an example of logarithmic and implicit differentiation. Find y prime if x to the y equals y to the x. We are given a relation and we are asked to find y prime. When in a question they ask for y prime, it means that we suppose y is a function of the other variable, which in this case is x. So we suppose y is dependent to x. X is in the independent variable and y is the dependent variable. So y prime actually means dy over dx. To find the derivative of this function, we use logarithmic differentiation technique. Before doing any derivative, we take ln from both sides of the equation. The reason that it is a good idea to take ln from both sides of the equation is that with the aim of ln, we can bring the power to the front. Note that here, the base and the exponent both are dependent to a variable. And finding the derivative of this function in this given form is a bit hard. So it's a good idea to first take ln from both sides of the given equation. If we add ln to the left and right side of the equation, we have ln of x to the y equals ln of y to the x. Remember that ln has this property. ln of a to the p equals p ln of a. So ln of x to the y is y ln of x, and ln of y to the x is x ln of y. So we have y ln of x equals x ln of y. Note that this property of ln, that we can bring the power down to the front of ln, has nothing to do with the power rule in derivative. In the power rule in derivative, we bring the power down to the front and we subtract by 1. But here, this is one of the properties of ln, which when we take ln from both sides of this relation, we can bring the powers down to the front of ln's. Now let's take derivative of left side and right side of this relation. To find derivative of left and right side of this equation, we need product rule. Because note that between y and ln of x is multiplication, y times ln of x, and x times ln of y in the right side of the equation. So we need product rule. And also because there is ln here and here, we need to remember derivative of ln. Let me here remind you derivative of ln of some function. ln of an expression equals 1 over that expression times derivative of inside, which here is f of x becomes f prime of x. So again, derivative of ln of something equals 1 over that thing multiplied by derivative of inside. And let me remind you product rule. Derivative of f times g equals f prime times g plus f times g prime. In another word, derivative of multiplication of two expressions is to take derivative of each of them, multiply by the other one, and add them together. So, if we take derivative of left side of the equation, we have y prime. Note that f is y and ln of x is g. Take derivative of y, derivative of y is y prime. Because y is a function, derivative of y is y prime. Multiply by ln of x. Multiply by the other one. Plus, copy the first function, y is the first function. Multiply by derivative of the second function. Derivative of ln of x is 1 over x. And derivative of inside is 1, so we don't need to multiply by 1. So derivative of ln of x, 1 over x. Now let's do derivative of the right side of the equation. Derivative of x times ln of y. Again, we use product rule. First, take derivative of the first part of the equation. Derivative of x is 1 multiplied by the second function plus x, copy the first function, multiply by derivative of ln of y. Derivative of ln of y is 1 over y times y prime. Derivative of ln of something is 1 over something times derivative of that thing. So derivative of ln of y is 1 over y times y prime. Don't forget this y prime. Before going to the next step, let me simplify this expression. Y prime ln of x plus y times 1 becomes y over x equals 1 times ln of y is ln of y, plus x times 1 becomes x over y times y prime. Now, to find y prime, we have to move the terms involving y prime one side of the equation and the other terms to the other side of the equation. We want to find y prime, so we have to try to isolate y prime. So we move the terms that have y prime to one side of the equation. This term, y prime ln of x, and this term, x over y times y prime, have y prime. So I'm moving this term to the left side, and I move y over x to the right side. If we rearrange this equation, we have y prime ln of x minus x over y times y prime. We move this term to the left, it becomes negative, equals ln of y minus, we moved this term from left to the right, so it becomes minus y over x. To find y prime, to isolate y prime, we factor y prime from this term and this term. If we factor y prime, we have y prime bracket ln of x minus x over y. From the first term, ln of x remains, and from second term, minus x over y remained. And we write the right side of the equation as it is. Finally, to find y prime, we have to divide both sides of this equation by ln of x minus x over y. So finally, y prime equals right side of the equation in top, this expression in bottom, because we are dividing both sides of this equation by ln of x minus x over y. So y prime equals ln of y minus y over x all over ln of x minus x over y. If you want, you can rewrite this expression in this form. With a little algebraic operations, you can get from this expression to this expression. Y times x ln of y minus y over x times y ln of x minus x. This is the same answer, but in another form. It depends to you which form you prefer. Both of these are completely correct, and they are derivative of the given function. Before I finish this video, let me show you how you can get from this expression to this expression. Y prime equals ln of y minus y over x all over ln of x minus x over y. To transform this expression to this form, first we have to try to get rid of these denominators, x and y here and here. To get rid of this x, it's a good idea to multiply this expression by x. And to get rid of this y, it's a good idea to multiply this expression by y. But we know that we cannot multiply just numerator by something or just denominator by something. So to get rid of x and y in denominators, multiply numerator and denominator at the same time by xy. If I multiply numerator and denominator by xy, we have this expression. Again, why we multiply numerator and denominator by xy? To get rid of these denominators here x and here y. Now if we multiply xy in the bracket in top and xy in bracket in denominator, we have xy times ln of y in top. If we multiply xy by y over x, this x from top and x from bottom cancel each other. Y times y becomes y squared. And similarly, if in the bottom we multiply xy in the bracket, we have xy ln of x minus xy times x over y becomes x squared, because y from top and y from bottom cancel each other. X times x is x squared. Almost we get to the second expression, but to make it completely similar to that, note that in top you have y and in bottom you have x in common between these two expressions. So we factor y from top and we factor x from bottom. If we factor y from top, we have x ln of y minus y. Note that we factor the y, so this y goes away and y2 becomes y. And similarly, if we factor x from bottom, we have this expression.